Bernard says yes. So welcome. My name is David Bolliker. I actually work for IBM. I arranged a night today where we're actually going to be speaking about Docker. And we actually have 3 speakers today. There's Aaron, who's actually he works for Docker itself, and Aaron's going to give you an introduction to Docker, where they're headed right now.
Hi, everybody.
Thank you, Aaron. Next speaker is going to be Dan Gisolfi, who actually works for IBM, and he actually is from my group in emerging technologies, and we're going to talk about how we're actually using Docker from an application standpoint, and what and how we're using it for. And last but not least, there's Dan Walsh sitting over there, who's actually going to tell us how Red Hat's using Docker. And Dan has got the back part of the hour, so he can run over for 2 hours, or until you all walk out. Then there's actually one other announcement, and Jay, that's your announcement.
Go ahead. Oh, okay. So our next meetup is going to be on August 14th, and being as August is generally a slow month, we're going to do it as a social mixer networking session with no pre-planned talks. So that's our we generally do that once a year, try to get a sense of how we want to, the kinds of topics we want to cover the following year, what kind of, what are the major trends that we ought to be trying to follow and bring new speakers for, etc. So the announcement will be out there as soon as I get my Wi-Fi working. And I do want to invite you to come and just enjoy everyone's company, and hopefully let's plan something for next year.
Where is it going to be?
Probably Mead Hall, but depending on how many people we get.
Okay, thanks, Jay. Aaron, it's all yours.
Hi, so David, I'm going to ask you to do me a favor and tell me if everybody could raise their hands about how many people are familiar with Docker and use it, one or the other.
I'd say about half, maybe even 2/3 of the audience knows about Docker.
Great, that's awesome. So I wanted to just sort of start with who I am. I'm Aaron Husledge. I'm a solution architect with Docker. I help customers and people out in the field implement Docker into their environments and make sure that everything works together. Kind of here to make you succeed, help you succeed. So that's who I am. And so today we're going to talk about Docker and what it is and why we're doing it and how it works. So Docker is a container platform. So we virtualize applications inside of a container on a Linux platform. So you can build, pack, ship, and run applications with containers anywhere and anytime. So everything is isolated in a little box. And what's in the box stays in the box and can run. So, this isn't really new at all. This is something that's been around for ages with things like BSD jails and Solaris zones and things like that. But what we've done is we've created a new format and a new set of tooling around that format for images to be able to be carried back and forth. So we have less overhead. We make it easier for developers to just develop an app instead of worrying about operations. And operations can just deal with the containers as their own thing. So they expose, a very small surface, and other people can, operations can just take that surface that's exposed and act on it. So it's a much more lightweight approach than a VM, for instance. So devs like it because it's, well, all of these things. I don't want to read the slides, but we allow devs to take exactly what they want and put it into the container based on something that needs to run in the environment. So all the dependencies, all of that runtime stuff that needs to be put together, all of the configuration, all that stuff just sits in the container and runs when you run it. So it's just like one binary running instead of, you know, like a giant Tomcat installation with a bunch of different stuff. Do you have any problems?
Yeah, Aaron, are you sending us slides?
Yeah, do you not see them?
Nope.
Do you see them now?
Nope. We actually saw them a few minutes ago.
Yeah, they were there, yeah.
Now I have a live video of you. Any Skype professionals here who use it all the time?
Is it working now?
Nope, we actually have you live. There's the slides. We got them back now.
Okay.
Albeit pretty small. No, we just lost them. Yeah, well.
This is the problem with screen sharing, right?
At the bottom.
Yeah.
Yeah, that.
Middle of the bottom?
Yeah, that's normally uploading up and down. Okay. I'd say for you to ship them to me, but we know the network is really slow. Well, actually, why don't you ship them to my Gmail account, Aaron, and I'll show the slides.
All right.
What if you down-res your
Yeah,
laptop?
Carissa says they're okay on her.
What's that? They're okay on
I think this is just some bandwidth issue. Problem is these are HTML, so
What's the
I don't
resolution
have
of your
an easy way to
laptop?
ship them to you. So you don't see them at all?
We're actually checking my resolution as we speak, which actually shouldn't be a problem.
Displays. Retina. Yes, if it's Retina, sometimes it scales weird. Oh, best for
That's
Crestron.
best for Crestron. Shouldn't be a problem. We don't have the slides again.
Okay, well, I will send them out to you afterward. How about that? And then you can send them out to the meetup. Would that work?
No, it doesn't let you maximize this. This? There we go. Thanks. That's why we need an expert.
So it's working now?
Yep, we're good.
All right. So as I was saying, we can fit directly into the development pipeline such that everything is that a developer needs to worry about sits inside of this container. You can run your own testing inside of it. You can do automated builds. You can do continuous integration, continuous deployment, etc. And make everything much simpler for you as a developer. And this goes from your laptop to the cloud when it's deployed in production. So all of these steps can fit in, and that's what operation like about it, because everything is repeatable and consistent. So everything is segregated. We typically suggest running one application per instance. So if you have, let's say, a Java database, a Java app front end, and like a messageware middle queue, or message queue middleware, agreed, or and a backend database, for instance, those would all three be their own containers, and that way they're all managed in their own world. So all of this stuff can be deployed and delivered and tested atomically. So the big advantage that we bring is that we can bring these things up in seconds, as opposed to an entire having a whole OS boot, having all of this, provisioning and stuff done on a virtual machine. When you run a Docker container, it takes however long the binary takes to run, because there's not a lot of operating system involved here. It's running on the kernel of the host operating system. And so we get a lot of speed of deployment, we get major portability because all we need on a box to run is a relatively recent Linux kernel and the Docker binary. So, which is just one binary because it's written in Go, so we can compile everything in one binary. We also get a lot of benefits from the way that we do layering of containers, and I'll show you more about that in a bit, which gives us density as well. So you can put thousands of containers on one physical server as opposed to 20 or 30 VMs, like lightly loaded VMs on a physical server. So we lower costs, we increase density, and we perform very well. So this is this tech stack. So we run on most Linux distributions. I haven't had any problems on any of them. You need C groups and namespacing in your kernel, which most of them have if it's a relatively recent, from like if you're a Red Hat shop, for instance, Red Hat 6.5 and up have everything we need, although technically we run on 6.4 as well. All of Ubuntu since 12.04, et cetera. We support a pluggable file system backend. So by default, we use AUFS, which is an out of tree patch for the kernel that works really well and allows us to do layering of file systems so that you see a consistent view of the file system, which also gives us things like versioning and stuff for free. We also can use ButterFS and Device Mapper as well, so you can do snapshots in those as well. And then for the running in containers themselves, we have a library that's built into Docker called libcontainer, which manages containers running on the operating system. Or if you're an LXC shop or you have some tooling around LXC, you're welcome to use LXC as well. So this is what the tech stack looks like. So at the bottom, you have sort of the main operating system on the machine itself. So you have the kernel and your namespaces and your C groups and your device mapper and all the file systems. And then you create a base image. So like for this instance, we'll use Ubuntu. And then you add layers on top of that base image. So this isn't really going to run the operating system. It's just an environment that contains all the libraries from the operating system and the binaries that need to be there for it to be called Ubuntu. There's no kernel, there's no any of that stuff. And then you add your applications on top of that base image. So like in this instance, you add Emacs as a layer on top of that. And then you add Apache as a layer on top of that. And these are immutable, so you're not going to write on them ever. They're just layers that when you build the container, that's what exists there. And then we have a writable layer on top of that you can use to hold application state or logs or kind of any of that kind of stuff. So that's the sort of basic sort of way an image works. And now we're going to go to what Docker Hub is and how that works. So when you build a Docker image, you have this thing called a Docker file, which is just a little short definition that says, these are the steps that I run to install Apache, for instance. So here you see from Ubuntu, which means that we're going to pull Ubuntu as our base image. Now on Docker Hub, which is our platform on the internet, we have a bunch of what we call official repositories, which are maintained by the community, but sort of vetted by Docker Incorporated. And these repositories, I could just show you really quick. I was logged in before. That's good. So this is Docker Hub, which looks a lot like GitHub. And it's where you can push and pull your applications from, or your containers from, excuse me. So we have a list of a bunch of official repositories that are, like I said, vetted by or maintained by the community. So CentOS, Redis, Ubuntu. But we sort of bless them. And so that's what this from Ubuntu is. And then you have a maintainer line so that somebody can get a hold of you and yell at you if something goes wrong. And then you just put a list of commands in these run commands. So we're going to install Apache 2, for instance, on this thing, and then set some environment variables and expose port 80 to the host. And the way that this works is Docker manages the network stack such that with IP tables rules, so that you can map ports back into the host operating system. So if you expose port 80, then Docker will, by default, do nothing. But when you run it, and I'll show you in a minute, will allow you to map that port to something else in the host world. So this is going to be port 80 on inside the container, because every container also has a network interface. Entry point allows this to be run like a command, so you don't have to say user has been Apache 2 when you run the container. And then these are, and it's immutable, so I mean it's something that we don't allow you to change once the container is built. And then the command that you pass then to it, which in this case is -p foreground. Everything in Docker containers needs to be run in the foreground because there's no init. So it just runs as a process. So then it's pretty easy to build the image. You just type docker build, and then you push it up to the Docker Hub registry, which is what I showed you a minute ago. I'm not going to go exhaustively through this because we don't have time tonight, but just want to give you a quick overview of this. And then you can run it. And so what this says is you run, we're going to run this container as a daemon. We're going to expose port 80 back into the host, the host operating system, the real operating system. It's not really the host operating system. And this is going to let Docker assign a random port for that to be mapped to. And then just verbose, and then a volume. So this is going to map var www myapp on the outside of the container to var www myapp inside of the container. So you can take your file systems and allow containers to have access to them directly. And then, they're not, these do not apply, no layers apply to these at all. It's just a bind mount into the container. And then what the name of the container is. And that will run Apache on port 80. Well, that was also working before, but I guess it's not now. I was going to do a quick demo, but well. So that's sort of the basics of Docker. It's very simple, very straightforward, and we think it's changing the way that people do things in the world. I'd like to know if there are any questions.
One, two, you're going to have to walk up to the mic.
Hi, Aaron. This is BK. I have a question. If you have a Docker container built off, let's say, Ubuntu, can you run it off, let's say, a Docker subsystem that is installed on, let's say, Red Hat, for instance?
Absolutely. Yeah.
So I'm a little bit surprised why that works. There has to be some. Isn't there any differences between the two operating systems, Ubuntu and Red Hat?
There's a lot of differences. The container itself runs an environment that is Ubuntu. So all of the libc and all the libraries that are inside it, that are run on Ubuntu, run inside of that container. So anything you run in there will look like, it'll think it's Ubuntu, but it'll be running on the Red Hat kernel. Because we just wrap everything around the way the container works is that it uses C groups and namespaces to create a virtual environment, basically. It's not a VM, but it acts a little bit like one for that kind of purpose. And these images they're pretty small. The operating system for Ubuntu is 100 and something meg, you know, or maybe more than that, maybe now, I don't remember. But definitely much smaller than a VM.
Hi, my name is Paul Collado. So I have two questions for you. One is, with VMs, one of the things that they give you is the ability to fail over the workload from one compute node to another. Is there anything like that in Docker or anything like that coming? That's question number one. And question number two is, I assume that when I'm running multiple instances of the same Docker container, that they're still sharing all of the images underneath. So those are my two questions.
So with regard to failover, there's nothing in Docker that manages failover at all right now. We have on our roadmap for next year or later this year some tooling to make that easier to deal with, but right now there's nothing that allows for failover. We are purely a kind of, the workloads that we focus on right now are purely, mostly stateless containers that can run, you know, multiple instances and have a load balancer type arrangement in front of them. With regard to running multiple instances, all the base layers are the same. Yes. So if you run Hustlage Apache 2 4 times, you'll get 4 different web servers, but they'll all be running with the same state that the container was created with. Now they'll diverge from there because when you start the container, you know, it creates this writable file system layer on top, and that changes over time. And you know,